Hello there. The first step to beginning the Extension 2 Mathematics course is to understand and go through the syllabus. The syllabus is essentially an outline for everything you'll be doing in the course over Year 12, as well as the aim and objectives, how you'll go about studying, and it outlines the assumed knowledge for the course. I highly recommend that you read through this yourself in more detail, but in this video I'll just be providing an overview, which will foreshadow how I will structure my lessons on the Maths Extension 2 syllabus over the year. The introduction, I'm not going to spend too much time on here. You can read through this yourself and all of these subheadings. And this is just the breakdown of the course. This page indicates the transition from Year 11 to Year 12 for the different mathematics courses. Given that you are studying Extension 2, we will focus on this bottom section. You should also note that since you will be studying Extension 1, you should look at this second from the bottom area, but I'll get to that in another video. So looking at the Extension 2 section, you'll notice the transition from Year 11 to Year 12. So in Year 11 you would have studied the Mathematics Advanced and Mathematics Extension 1 courses. Those totaled 3 units and 180 indicative hours of classroom work. In Year 12, you will be studying the Mathematics Advanced, the Mathematics Extension 1, and the Mathematics Extension 2 courses. Note that it says 2 units for Advanced, 1 for Extension 1, and 1 for Extension 2. This is not how the units will go in your ATAR. If you are studying the Extension 2 course, your Extension 1 will become worth 2 units, and your Extension 2 will be worth 2 units. Also note the indicative hours. You'll be studying 120 indicative hours for Advanced, 60 for Extension 1, and a further 60 for Extension 2. So in total, you will have 240 indicative hours of classroom work. This means that you will be dedicated around double the amount of class periods to maths as kids doing just advanced maths would be. It's also important to note that since you are studying 4 units of maths, as opposed to every other subject which are usually 2 units, you should be doing double the study of maths each night. So if you're doing half an hour of study for each 2-unit subject, you should be aiming for 1 hour of study for Extension 2 maths. And this should be divided between Extension 1, Extension 2, and advanced content. This page goes through the transition from all the stages up until stage 6, which is where you're at now. Now the aim of the syllabus of the course. The study of Mathematics Extension 2 in Stage 6 enables students to extend their knowledge and understanding of working mathematically, enhance their skills to tackle difficult, unstructured problems, generalize, make connections, and become fluent at communicating in a concise and systematic manner. So let's just break that down a bit. It will enable you to extend your knowledge and understanding of working mathematically. So that basically means you'll be studying harder content in a more detailed manner, but you'll be able to apply it more to the real world. And since you have that greater understanding, it will be more meaningful for you. I myself, during my study of the Extension 1 and Extension 2 courses in Year 12, found some overlap with the other subjects, and that really helped me during my studies and final preparations for the exams. You'll be able to enhance your skills to tackle difficult and unstructured problems. This is really an emphasis of the new syllabus, wherein both the Extension 1 and Extension 2 syllabi, it outlines that there'll be, I believe, at least 2 questions in the HSC worth in excess of 4 marks, with no lead-in. And this is really going to be the E4 question, which will be used to distinguish between good students and great students. So through your practice, you will ideally be able to tackle these unstructured problems. And then you'll be able to generalize and make connections between the different areas of maths you'll study. And this is really a true statement because while initially the different topics may seem disparate, they are truly all interconnected, and if you understand one area, such as vectors, it will enhance your understanding in complex numbers. And the markers will try to expose this in the exams, where they'll structure the questions so that multiple topics are involved. And you'll become fluent in communicating in a concise and systematic manner. Communication is really emphasized in the syllabus, and we'll get to that later. Objectives of the course. You can read through these. They're basically just some mathematical jargon. But it is good to know what you're aiming to do in the course, and hence what you'll get out of it. Now the outcomes. These are basically what the syllabus outlines you should achieve. So you should develop efficient strategies to solve complex problems using pattern recognition, generalization, proof, and modeling techniques. You'll develop your knowledge, skills, and understanding to model and solve complex and interconnected problems in the areas of proof, vectors and mechanics, calculus, and complex numbers. So that's basically just outlining the different topics and what you'll be studying this year. You will develop your problem-solving and reasoning skills to create appropriate mathematical models in a variety of forms and apply these to difficult unstructured problems. So that's similar to what I was saying before. And you'll use mathematics as an effective means of communication and justification in complex situations. Communication and justification we'll get to in a second. This is a brief outline of the course. I'll skip over this because we go into more depth later. Assessment and reporting. You should have a look at this, the content. So this illustration shows what you'll be studying in Year 12. And it shows that by getting these bread and butter tools of understanding, fluency, communicating, problem solving, reasoning, and justification, that will lay the groundwork which will allow you to expand your mathematics in advanced and the extension 1 courses. Then you'll use those to perform in the extension 2 course. Now, working mathematically. This is basically a bunch of syllabus jargon, but it does give some good insight into how you can address questions, and therefore it will show you which types of questions they can ask. So we've got 6 aspects. So we've got reasoning. You'll analyze, evaluate, explain, infer, generalize, deduce, and reach conclusions. So what does that mean within the scope of mathematics? You know what it means within English, so analyze is saying this does this. In mathematics, analyze means to investigate a problem and find solutions. So in mathematics, whenever you're doing a question, you're constantly looking to analyze the problem and find a solution to it. Communicating. This is really emphasized in the syllabus. Describe, represent, formulate, express and explain mathematical situations, concepts, methods, and solutions to problems using a variety of presentations utilizing appropriate language, notation, and diagrams. Now, the new syllabus does emphasize a lot of technology usage, which we'll see when we get into each topic. And communicating is a key part to this. And communicating, it's not just what you write, it's how you write it. Even in an exam, you want to be really neat with your working, and that will allow you to communicate your understanding effectively and thoroughly to the marker. Fluency. Recall factual knowledge and concepts, and select and apply appropriate procedures flexibly, accurately, and efficiently. So this is basically just how well you know the content, and then how well you can apply it to the question. So a lot of the most difficult questions in recent years have been ones where it's not initially obvious how you approach the question. So if you're very fluent with your mathematics, just like if you're fluent with a language, you'll be able to know how to address these questions even when they don't give you a lead-in or when they don't tell you. Understanding. Make connections between experiences and related concepts and progressively expand and develop ideas. So this is back to this idea of the whole scope of mathematics is really intertwined and interconnected. and by thoroughly understanding one aspect, it will enhance your understanding of the rest of the course. Justification. Justify strategies and strategic thinking used, conclusions reached, and explain the reasonableness of findings, proving results where appropriate. So justification is really prevalent in the topic of proof, where you'll need to find a conclusion and potentially justify how you got there. But implicitly, you're always justifying your mathematics, because you're never going to skip from the question straight to the answer. You're always going to have some working out. Your working out justifies where you're going and how you get there to reach the final answer. The sixth aspect of working mathematically is problem solving. You will interpret, formulate, investigate, model and solve problems using mathematics in simple and complex, familiar and unfamiliar situations. So that's the process of how you're going to be answering a question. First of all, you will interpret the question. What's it giving you? What's it want? Then you will formulate how you will respond to the question. Just like as if you're doing an essay in, say, English, you do a plan. You do the same thing in mathematics, usually subconsciously, because you would have practiced so much that you just immediately know how to approach the question. But on those more difficult, the more complex, unfamiliar questions, you will need to formulate a plan. Either in your head, maybe you could write down notes quickly of how you're going to solve the problem. And the binary between simple and complex and familiar and unfamiliar is shown through the progression of the exam as you go from question 11 to question 16 in the extension 2 paper. The question 11, 12, even 13 and 14 to an extent will usually be questions you've seen before or in the style that you've seen before. Sometimes they'll even put questions in from previous years, just with a small tweak. However, questions 15 and 16 will usually be far more complex and unfamiliar. They will be worth more marks, and those are the ones where you'll really need to stop for a minute and think how you're going to solve it. And those will take more time to interpret and formulate the question before you finally investigate, model, and solve them to reach the final answer. These 6 aspects of working mathematically are embedded across the range of syllabus objectives, outcomes, and topics. Teachers extend students' levels of proficiency in working mathematically by creating opportunities for development through a range of teaching and learning activities they design. So basically, you shouldn't be passive learners, just listening to the teacher or listening to myself. You should be actively looking to engage and answer questions. Go beyond the work they set you, which will help you to achieve these 6 objectives of working mathematically, and that will really allow you to perform well in the end in your exams. The Mathematics Extension 2 Year 12 course content. Before I go through these topics, I think I really need to emphasize how important it is to really understand your Year 11 content in both Extension 1 and Advanced. And throughout the year, you need to make sure that you really hone in on the Advanced and Extension 1 topics, because these topics lay the groundwork, which, as I said before, are expanded upon in the Extension 2 course. A lot of the time, the questions which catch out the good students are really simple, and they just ask on the Extension 1 or Advanced content, which you wouldn't expect to see in the Extension 2 course. An example of this was in the Extension 2 paper this year, 2020, the first paper of the new syllabus. You wouldn't expect to see a projectile motion question in the Extension 2 course because, of course, it's part of Extension 1. Nonetheless, it was in the paper, and we'll have to wait and see. It may have caught a lot of students out. Okay, now on to each of the topics. While the syllabus outlines the topics as going proof, vectors, complex numbers, calculus, and mechanics in that order, While the syllabus outlines the topics as proof, vectors, complex numbers, calculus, and mechanics in that order, in my lessons I will not be following this set order. I will first begin with complex numbers, because it can be taught separately from the Extension 1 and Advanced content. I also believe it's the easiest of the topics in the Extension 2 course. I'll then move to vectors, and later on I'll decide whether I go on with mechanics, calculus, or proof next. But just know that the first topic will be complex numbers. So let's go to complex numbers now. Okay, so the topic focus involves investigating and extending the understanding of real number system to include complex numbers. During my lessons of complex numbers, I'll expand out on what they actually are, how we use them, their applications to the real world and the world of mathematics, because they truly are an important thing which is used in the real world a lot. So it's broken down into different subtopics, and as we go through the year, I'll be ticking these off, and as we finish a topic, I'll go through and I'll confirm that we've gone through all of these in a video. I also encourage you, as both I and your teachers go through the course, to tick these off, just so that you make sure you know everything, and you can refer back to anything if you are unsure or require additional assistance. Now, the complex numbers topic is broken up into two sections. We've got first, the introduction to complex numbers. This is basically an outline of complex numbers, what they are, some applications, some different forms of complex numbers. There's three forms. We've got the Cartesian, the polar, and the Euler form. We've got some identities, and then just solving problems with the complex numbers. I would rate this first bit as a 6.5 out of 10 on my scale, where 10 would be the hardest topic in the courses. This same scale I will use for the Advanced and Extension 1 courses once we get to them. The second part is using complex numbers. This is a bit more complicated as it involves some theorems. We'll see that we get some exciting new ways to derive the trig identities, which you've already done. And then we go into loci and other things, which is really interesting, and you should look forward to that. I would rate the using complex numbers as an 8 out of 10 in terms of difficulty. The next topic we'll go to is the vectors topic. So vectors you will study 2-dimension in Extension 1. However, in Extension 2 we will extend that to the 3rd dimension. Although I don't think the vectors 3-dimension makes it too much harder once you wrap your head around this idea, which is a bit foreign compared to your study of the Cartesian plane in younger years. The vectors topic, I would rate it as a 7 out of 10. Proof is also broken up into two sections. First, we've got the nature of proof. This is going to be a bit different from what you've studied in younger years. You'll be able to use things which you've seen before, such as the triangle identity, but through this foreign study of a new area of mathematics, I think it will enhance your understanding and help you to perform better in all areas of the syllabus. I would rate the nature of proof as the hardest part in the syllabus. I'd rate it as a 10 out of 10 for difficulty. The second part is further proof by mathematical induction. So you'll study mathematical induction, summation, divisibility, and false proofs in the Mathematics Extension 1 course. However, in the Extension 2 we'll go into further proof. So this will constitute things like induction using derivatives, trig, and a lot of other techniques. It is a bit more difficult, however it is not too difficult, and I think once you get your head around it and the different forms, I think you'll be able to master it. I'd rate further proof by mathematical induction as a 7 out of 10. The fourth topic is the calculus topic. So you've become familiar with calculus in terms of differentiation in your Year 11 Advanced and Extension 1 courses. In Year 12, you'll study integration, which is essentially the reverse process of differentiation. You'll do this in Advanced, Then in Extension 1, you'll come across harder problems, and they'll give you techniques to solve those. However, some of those problems, they'll give you lead-ins and tell you how to solve them. In the Extension 2 course, they will most likely not give you a lead-in or tell you how to solve the problem. So further integration, that will be things like integration by parts, integration of trig identities, integration by substitution, partial fractions, where they don't tell you how to solve it. The most difficult and important part of the further integration topic is to understand all the different methods and when to apply each of those. I think once you've mastered that, you'll be able to answer most of these questions quite well. One other part is the reduction formulae. I believe that the reduction formulae on itself is one of the hardest parts of the Mathematics Extension 2 syllabus. The calculus topic is one of the hardest ones in the Extension 2 course. I would rate it as a 9 out of 10 for difficulty. Now the last topic is mechanics. I believe mechanics to be perhaps the most fun topic in the whole course, and also the most fun topic out of all the 3 courses. This is because through modeling both simple harmonic and resisted motion, it will give you a greater understanding to motion in the real world. In Extension 1, you will study projectile motion, which ignores air resistance or any other form of friction. However, in the Extension 2, we will be able to model resisted motion. This is really fun, and it encapsulates various parts of mathematics such as differential equations, integration, trig, and other form. It's really a part of the course where the markers will look to combine multiple areas of mathematics into one, and where they may ask you one of those longer questions without the lead-in. We also will study simple harmonic motion. Now this was previously in the Extension 1 course, and now since the new syllabus it has been moved to the Extension 2 course. I would rate the mechanics topic as an 8.5 out of 10 in terms of difficulty. Now that we've gone through the different topics in the Extension 2 course, I will briefly compare the new syllabus to the old Extension 2 syllabus. The old syllabus had circular motion, it had a more in-depth graphing topic, and it had harder Extension 1 topics. This has been replaced with more calculus, vectors, and the introduction of Euler's formula to the complex numbers topic. While I do believe that with the new syllabus it is easier topics, I think that in order to balance this out, the markers will tend to make the papers harder. While these new topics are easier, it doesn't mean that you should dedicate less time to the course, because it still is a difficult course and it will require a lot of study time in order to do well. Also remember that it doesn't really matter because you're competing against the rest of the state, and it will be the same difficulty for everyone. Everyone sits the same test. Now we go to the glossary. These are a bunch of mathematical terms we'll get to know throughout our study in the course. I don't recommend getting to know these definitions because you'll become quite comfortable with them as you study each topic. And that brings us to the end of the syllabus. Now in your study of the Extension 2 course, I strongly urge you to continually refer back to the syllabus to make sure that you've got a good understanding of every topic and all the subtopics. In your study, I recommend that you pay close attention to the Extension 2 paper for Year 12 2020. Also, the NESA sample paper for the new syllabus provides some good questions, and I strongly recommend that you go through this as well during your study. For other questions on the new syllabus content, I recommend other courses such as the VCE, the IB, and the GCSE, as they all have questions on the new topics. Looking at the breakdown of the 2020 Maths Extension 2 paper in terms of by topic, vectors had a total of 20 marks, complex numbers 14, Mechanics was 30. Further integration was 18. And proof was 18. As you can see, the paper was more weighted towards mechanics. The paper was also a bit on the easier side, but this does happen from time to time and isn't necessarily an indicator of future years under this new syllabus.